Good day, learners. Welcome to today's geography lesson. My name is Rajendra Devchand. Dave as in simple. And this lesson, I must say, is proudly brought to you by the Gauteng Department of Education. Now, you know, learners, that this lesson is interactive. So we have a WhatsApp interactive number, and it's 082 760 2630. It's 082 760 2630. Okay, so if you have any challenges, I do have my expert colleague, Portia January, available with me. We do have larger amounts this is quite a summary dealing with the important aspects of climate and weather. But if you want more sort of exaggerated and comprehensive notes and little videos that you can watch later, my colleague Portia January has them available. So on WhatsApp, you can request that. Okay, so let's get started. All right. Our session today, as I said, is climate and weather. And I'm going to move to my first slides. Again, the approach, learners, is to keep it simple. We're going to use resources that we would generally find in any sort of question paper, books, etc. So you get used to using those type of resources. So past papers will be used. Now, you know this is paper 1, all right, where climate and weather together with geomorphology, and we'll get a bit of map work that Mr. Ne had mentioned to you in our last session on the 30th of September. Now, I don't want to go over sections that he has covered, all right, like mid-latitudes and tropical cyclones. He's already covered that. But if you have further challenges, you can request my dear colleague Portia January to send you further slides on that. So, one thing just to note already, and this has been sent to our province, that the paper will change slightly, all right? Normally you had a question paper and an annexure and a map, all right? Now you're going to get a situation where all the resources, your diagrams, your tables, etc., are going to be found on the question paper. So no more annexure separate. Your diagrams are going to be on the question paper. I'm sure you'll be happy with that. Otherwise, you're sitting with annexure question paper, and then you're sitting with a map, and you're sitting with your answer booklet. You've taken away one thing. So please note that, all right, with regards to that change. So when I'm looking at this, learners, I'm looking at the climate and weather, and then I'm looking at the mid-latitude cyclones down here, all right, which Mr. Ne had done on the 30th of September. But as I say, if there's further challenges, please let my colleague, Ms. January, know, and she would then send you stuff. Or if there's any specific questions, we'll do our best to handle it. Then we're looking at also the tropical cyclone that Mr. Ne had completed the last time, again on the 30th of September. So those two have been covered. But again, if there's further questions, I know I'm repeating myself, you are welcome to ask or ask for further material. But what we're going to focus here on, all right, is this little section. And many learners and teachers have come up with areas that they feel there will be challenges here. How do we see these tropical and mid-latitude cyclones on a synoptic map? How do we read the Berg wind? How do we see rainfall? Why do we see rainfall? How do we read weather conditions? And, you know, it's an important aspect. So I'm going to use 3 different synoptic maps to try and bring out the essence or the significance and the application of that. Okay, so I'm going to take that from your mid-latitude and your tropical cyclones, and I'm going to do that in more detail and application. So let's get going with that, learners. And again, I'm trying to find my little switch here. I'm getting old, I think. And to turn to the next slide, all right? Now, before we even look at the weather symbols or the synoptic map, we do need to look at something. And learners, you've done this before. You've done it in your earlier grades 10 and 11. And that's your weather symbols, okay, and your weather station. I'll show you later on how important this is when you work out the influence of different climatological phenomenon that's going to affect. So, let us look at the, first of all, we look at the wind speed. Now, learners, I know many of you say, but what is 5? Is it the shorter one, the longer one? And I'm sure your teachers would have emphasized to you that when you read 5 knots, the line is not at the end. It is at the middle, or not actually the middle, but slightly higher up. So that is 5. And of course, a full line at the end is 10, 15, 20, 25 knots is 2 long lines and 1 short line. So that's how you read the wind speed. Okay? Of course, you don't get many of these, but I just put it there out of matter of interest that you know that when it's 50 knots, it's a little triangle. Of course, when we look at this, you will notice the wind direction is coming from a northwesterly direction. Okay, so we look at the direction, it's northwesterly that it's coming from. That's how you read your wind. And obviously, this is your different current weather situations. All right. And of course, this is your cloud cover. These are the basics you've done before, but we don't forget the basics in order to understand the later phenomenon. All right. And of course, 0, 1/8, 2/8, 3/8, and we go on right up to completely overcast, which is 8/8. So let's look at this very quickly. This part represents your air temperature. And what's our air temperature? Is it 12? I'm going to mark it wrong. It's 12 degrees Celsius. Dew point temperature is 5 degrees Celsius. All right. Wind speed is 15 knots. Wind direction, northeast. All right. And then we look further. And we look at that there's some current weather or precipitation. Okay, and the dot would represent rain with possible showers. So do you know, learners, if you know this off, maybe you can get a job as the newsman on the television. All right, because this is what they read. Okay, so maybe I'm training you for that also. All right, so we got an idea of the weather phenomenon. Now let's start looking at a synoptic map, all right? Now, this is the first one I have here. All right, I'm looking at what do I see here? First of all, I look at South Atlantic High. You don't write it in short, learners. We'll mark it wrong. South Atlantic High. I'm just doing it now quickly. South Indian High. All right, immediately what do I notice, learners? That they are in their southerly position. All right, already I can work out by them being in the southerly position that it is a summer condition. All right, I notice there's a low here, a possible thermal low, okay, that's occurring here. So I know the land is hot, it's dominated by that. I'm also noticing cloud cover on the east. And I'm wondering, why is there cloud cover? Overcast conditions. Okay? And this is where you take your phenomenon that you studied in climate and weather and you start applying it. All right? So, let's look at here. Can you see a ridge forming? All right? From the high pressure, this elongated pattern. Okay, and this possibly is moving towards this low, all right? And as it's moving towards this low, it's bringing in moist conditions, all right? And therefore bringing in those cloud covers, because as it goes over the hot land, it's going to heat up, it's going to rise, it's going to condense, it's going to form clouds. Can you see the phenomenon here? So do not neglect your synoptic map, because it brings climate and weather alive. You can actually see it happening here. All right, so thank you, DB, for this past paper, all right, that we used. Let's look at here, Durban. Now you know it. Air temperature, 27 degrees Celsius. Dew point, 26. All right. Cloud cover, 6/8. And then if you look here, it's not at the end, it's there. So it's 5 knots southeasterly. Can you see how we can work things out, learners? By understanding this. But let's just go to a few questions. This was the 2021 June paper, okay, that we're using now. All right, look at this. Give evidence from the synoptic weather map that the synoptic weather map represents a summer condition. Can you see? Already you're determining seasons, and that's already relevant. All right? I'm going to go back. Right, you know, high temperatures, thermal low, high pressure system, South Atlantic, South Indian are in their southerly positions. They're blocking the cold fronts from coming in. Overcast conditions on the east. Can you see? You already determined it. So one of the ideas here, learners, is you have to interpret your resource before you start answering your questions. It is so important. We jump the gun. As people say, we question happy. We just want to go to the questions. The resources give you so much detail. Okay, I'm going to go to the next question. Determine the isobaric interval of this. Okay, the difference in pressure between the isobars. Okay, and if I look back here, all right, I can see it's 1008, 1004, and of course, the difference is 4 millibars. Not 4 millibars. You must put the unit in, otherwise it's not right. All right, let's go again and look at the next one. Name high pressure cell A. Can you see, learners, you've already worked out so much of the synoptic map or the questions based on the synoptic map before you looked at the questions, so you can become good examiners also. All right, so I'm going to go back, and you know A is the South Indian Eye. All right, and then we go back again to the next one. State the wind direction and wind speed, and you already knew. You worked it out. Southeast and 5 knots, because it's not right at the end. Then it says comment on the current relationship between the wind speed and the arrangements of the isobars on the eastern half. Okay, and when I look at this, I see that it's ridging in towards the low pressure, and therefore the isobars are further apart. And if isobars are further apart, as shown here, it shows you a gentle pressure gradient. Can you see the phenomenon that you learned in grade 11, grade 10, etc. is also used here. So don't forget those things there that are linked to your matric exam. Okay. And of course, lastly, explain how high pressure cell A and low pressure cell in the interior of the country could contribute to increased rainfall on the eastern half of the country during summer. Now, this is how we learn sometimes, and we get some sources that tell us, and I'm going to go back, that, oh, because there's a high pressure over the sea and a low pressure over the land, therefore we're going to get cloudy conditions. You have to take in all you learned about air moving in a tropical cyclone as it rises. Okay, when it's heated towards the eye, it moves up, etc. Using the same principles I can see here. Number one, there's a low pressure here. Obviously, high pressure is going to move to low pressure. But it's not just about the high pressure and the low pressure that's going to bring the overcast conditions. What do I notice here? There's a huge part of the ocean. All right, and that's what we forget to mention. So if this air is going to move, it's going to cover this ocean, it's going to have a large fetch here, and it's going to bring all this moisture in. Okay? And as the moisture is coming in towards this thermal low, there's going to be heating, advection, and it's going to rise. Okay, but also here, it is relatively warmer. So what's going to happen? As this large amount of moisture comes in, okay, I think we're back on the new slide here, but again, so what I was talking about is the large fetch down here that would bring in this huge amount of moisture, etc. So we're using all our stuff in order to understand this. All right, I'm going to go to the next slide. Okay, let's look at this one, learners. And I'm going to get I love my highlighter. I know you'll know that. So I'm going to try and get my highlighter again. Okay, so let's look at this slide, learners. Right. What do we notice now? And this is where you see this, you learn it in mid-latitude cyclones. There is my South Indian high. There is my South Atlantic high. And what do I notice? Because the ITCZ has moved up into the northern hemisphere, the high pressures have followed it. Okay. And now they are in the northerly positions. And if they're in the northerly positions, what happens now? It allows the cold fronts to come in. Can you see that? So now we have a different situation. The cold fronts are moving in, reducing temperature, and we talk about frontal rainfall, we talk about the mid-latitude cell, the cyclone, and the cold front forming a wedge and uplifting the warm air to form the frontal rainfall. All that you've learned, you're now putting it into a synoptic map. And it's so easy, learners. Let's say if I created a high-pressure cell here, a massive high-pressure cell here, that's your Kalahari high. I could pose you a question because there's the coastal low here, and I could talk about Berg winds. Can you see that? So we could talk about various phenomena, but you can see the difference now in terms of the movement and the cold fronts coming in. You can see an occlusion happening here, and this is a cold front occlusion because the last symbol is a cold front symbol. This is the oldest one because it's further east. There's so much we can do with this. So analyzing this will be so important for you. I'm going to go to one more because you can see I really love synoptic maps, learners. Okay? And I want to look at this one now because you want to know about a tropical cyclone. You want to know what's going on. How does it happen there? Of course, firstly, there's a symbol. Can you see it on the synoptic map? There's a name, Beira, okay? And this tropical cyclone has moved in. Tropical cyclone Beira. It's the second cyclone to hit the region, okay, because it's B. And then I'm going to see here what stage is this cyclone in. First of all, I look at the land. Can you see it? It's going over land. So if it's going over land, there's less friction. Or there's more friction, rather. Okay, and if it's more friction over land, it's going to slow it down. There's less humidity, latent heat. All right, less latent heat will be given off. So less heat, it'll cool off. And notice here, what happened to that forward left-hand quadrant? The isobars have moved further apart because it's moving over land. Yeah, the isobars are closer together. It's still quite intense there because it's over the warm Mozambique current, all right, which is still feeding some heat into it. Okay, can you see now? Different areas will show you different intensities. So this is definitely in the dissipating stage. Okay, as it's moving away from the warm ocean, the isobars are getting more far apart, showing you a more gentle pressure gradient, and therefore it's dissipating. Learners, you can revise the whole of the climate and weather on your synoptic weather map. All right, you can revise line thunderstorms, you can revise Berg winds, you can revise mid-latitude, tropical, and it illustrates to you what is actually the differences here. Okay, so I hope that made a little sense. Go over your synoptic maps, don't leave them. All right. Right, so what I'm going to focus on now is, because Mr. Nair has covered the other parts of tropical and mid-latitude, I'm going to focus on the other sections, all right, in terms of your subtropical high-pressure systems, all right, and their resultant weather over South Africa. Now, these three pressure systems that you focused on, the Kalahari High, the South Atlantic High, and the South Indian High, plays such a big influence in terms of our weather, actually. Okay, it determines a lot, and I'm going to show it to you how it actually goes about. All right, so I'm going to go to the next one, and I'm going to look at here. All right, now, you know the three. On the west, the South Atlantic High. On the east, the South Indian High, and over the interior, the Kalahari High. So this one is your strongest one because it's over the cold Atlantic Ocean, all right, with the cold Benguela current. This one is a bit weaker because it's over the warmer ocean. And the Kalahari High changes in intensity also because during summer, it's weakly developed, and during winter, it's more strongly developed because it's colder and there's more subsiding air. Okay, so let's look at how these high-pressure systems actually influence the weather patterns over Southern Africa. All right? Now, I want to show you something here. All right, we've already discussed it in terms of a synoptic map. Okay, I'm getting comments about changing my pen. Learners, I don't think you like my pen, and yellow is my favorite color. But anyway, we'll change it, eh? You've requested that I use a red pen, so I'm going to do my best, and I hope it's coming in red. All right, there's the three high-pressure systems, and I think it's still coming a bit thick, and I must go thinner. Let's hope, yes. There we are. So I'm going to have a bit of a shake. You know, it's my age and my hand shakes a bit. Okay, so we got our three pressure systems, all right? And already you can see something in the first diagram. It's in its northerly position. So what does it do? The three pressure systems, they are the big bullies here. They determine whether that cold front comes in. You understand? So they're in the northerly position. And because they're in the northerly position, they will allow the cold front from coming in. So that high pressure or the subtropical anticyclones play a big part in terms of allowing the cold fronts to come in, causing frontal rainfall, decrease in temperatures, and all that. Now, let's take summer. Remember I spoke about the ITCZ there. Okay, now let's take summer. The ITCZ is in the southern hemisphere. So then the high pressure cells will be in their southerly positions. And when they start ridging in, they will say, no, no, Mr. Cold Front and Mr. Mid-Latitude Cyclone, you are not entering, all right? We'll push you further south. Can you see it? Yeah, they're in the southerly positions, all right? It's related to that. And can you see it's pushing the cold front further south? And here they are in their northerly positions and they're allowing the cold fronts to come. So already they play such a big part in determining the weather conditions that will take place in terms of the summer and winter conditions. Okay, now let's go through. Actually, red is not a bad color, eh? I see. Thank you, learners, for telling me that. All right, let's look at another thing that the subtropical anticyclones can actually determine. And it plays a big part for you Gautengers, on the Highveld, for you guys in Gauteng. All right, let's take two situations here, learners. All right, and I've got a little summary here also, but I'm going to focus on the sketches. You will get copies of all these things. All right, let's take this. This is winter. And of course, my writing is terrible. And this is summer. Now, what will make this winter and make that summer? Of course, can you see this is the Kalahari high pressure system on both sides. In winter, we know it's colder. And what did we learn the basics in climate? There's more subsiding air. So during winter, that Kalahari high is strong. It's big. And there's a lot of subsiding air. So what is it doing? There's a large amount of subsiding air. All right. And what does it do to this inversion layer? All right. It pushes the inversion layer below the upper level of the escarpment or the level of the plateau. It pushes it down below. Can you see it? Now, it's summer. And we've learned about high pressure systems. It's hotter. So there's less subsiding air. Can you see the subsiding air has reduced? Now what has happened? Because there's less subsiding air, the inversion layer is above the level of the plateau. Now what does that do to our weather conditions? When it's below, it will stop the moist air from coming in. Can you see it? And when it's above the level of the plateau, it will allow the moist air to come in during summer. Okay, so during winter, that is why we notice in Gauteng, learners, that there's very little or no rainfall. Okay, climate change may have a bit of influence where we get different types of conditions, but generally there's not much rainfall because the moisture coming in from the coastal regions is limited. It's not that much, okay, or hardly anything. So we have something called seasonal droughts here. In summer, rainfall. In winter, very little or no rainfall. But what happens in summer here now? Because the inversion layer is above the level of the plateau, what's happening? Moisture is coming in. And if moisture is coming in, then you will have more rainfall in summer. Okay, can you see that? So it's about the continental heating also, as mentioned here. Because the surface is heated, there's more rising air here. Therefore, the inversion layer is higher up. Can you see it? Yeah, there's cooling of the continent, more subsiding air, and it's below the escarpment. Yeah, it's above the level of the escarpment. Yeah, very little or no rain. All right. Yeah, there's more humidity, cloud cover, smaller temperature range also. I know you may have picked, you want to go pick on that. Why? Because if it's dry, if air is dry in winter, then you're going to find it's going to be the difference in temperature between the maximum and minimum will be great. Because during certain parts when it's night, it's very cold. During the day, there's no humidity to absorb the heat, so the heat hits directly. So we could get a temperature range of maybe 3 to 20. Yeah, there's humidity. So humidity traps the heat. All right, so we could get temperature ranges of between 13 and 19, much smaller. Okay, so we're seeing this mid-latitude anticyclonic movements or pressure systems that play a huge part in our weather. All right, let's go on. It's not the end. There's more that does this. Okay, let's look at the traveling disturbances. Now, traveling disturbances, again here, learners, it's related to our anticyclonic circulations. Traveling disturbance because these systems move, okay, and it takes place. So your favorite I'm going to touch on first, moisture front and line thunderstorms. Okay, I know it's your favorite. And we're going to keep it simple, all right, so that we don't get into this unnecessary detail, what we need to focus on here. All right, let's look at this moisture front and line thunderstorms first. Okay. And I'm moving forward, and there we are. All right. Now, Very simple, learners. Okay? First thing, it happens in summer. Please, we don't want to see in any of your papers, beautiful winter's day, we get line thunderstorms. You must remember summer. Okay, what did we learn? That the high pressure systems, the South Atlantic High, South Indian High, are in their southerly positions. Okay, because it's summer. All right. We'll notice as when we looked at that synoptic map. Can you see how synoptic maps help you, learners? That the land is dominated by low pressure, well-formed low pressure systems. Okay, generally. All right. So we picked up that. And then the basic principle, learners. How does air move from high pressure to low pressure? And what else did we learn? And I'm trying to simplify this. This is such a simple concept, but we tend to struggle because we don't go back to the basics. And what did we learn about circulation? That around a low pressure, it's clockwise in the southern hemisphere. And around the high pressure, it's anti-clockwise. And it moves away from the high pressure towards the low pressure. Can you see those basics now? All right, and I'm sure your teachers will be telling you, learners know the basics in order to understand something that's a little bit more complicated. So I've got the basics. I know southerly position, South Indian High, South Atlantic High, well formed over the oceans, or rather it's over the oceans. There's low is dominating the land. And we're ready to talk about clockwise, anti-clockwise movement. So let's look at this. Obviously, the South Indian High is moving over the warm Mozambique current and the warm Indian Ocean. So it's going to bring warm, moist air. Okay, and there's the anti-clockwise, and it's going to move towards this low pressure area. All right? Now, it's not going to move in just a line like that. All this is going to move in. Okay. Now, we also learned that the South Atlantic High is blowing over the cold, or air from the South Atlantic High is blowing over the cold, drier oceans. So what is going to bring in? As it moves, all right, in its anti-clockwise, it's going to bring cold, drier air. Now, you've learned another principle. Okay, when cold air meets warm air, which warm air is lighter, the warmer air will be pushed up. All right, it'll be uplifted by the cold air. But there's an area that it's actually a dry line that separates the warm and cold air. That's known as your moisture front, although it's a dry line. It's a moisture front. So along this thing, when the cold, dry air meets the warm, moist air from the South Indian Ocean, what happens? The warm air will be pushed up. And as it pushed up, there will be rapid upliftment. This is cold air meeting this warm air, and it shoots up. What's going to happen? You're going to have massive condensation along the moisture front. But on the eastern section. Why on the eastern section? Because that's where the moisture is. Okay, we're going to have it on the eastern section. Moisture is going to be uplifted. And what you're going to have all of a sudden? Huge cumulonimbus clouds and line thunderstorms. Called line thunderstorms because it occurs along the moisture front. And that's your line thunderstorms. It doesn't occur for days. It's a short occurrence. But it's a massive storm. It can cause lots of damage, infrastructure damage, damage to crops. You understand? It can also supply water, okay, which is valuable for usage. Okay, it fills up dams or storage dams and reservoirs, etc. But it can have positive and negative, as your teachers have told you. Once again, it only occurs in summer when a low pressure dominates the land. We're not going to always get line thunderstorms, otherwise we're looking for tragedies if we get it every day. A low pressure must dominate the land in order to have this line thunderstorm. So very quickly, moisture develops where cold, dry air from the southwest of the country, okay, from the South Atlantic high, meets moist air coming from the northeast, from the South Indian high. All right, the moisture front is a dry line separating these two. All right, that's your moisture front. The cold air lifts the warm air from the northeast, which cools, condenses, forms cumulonimbus clouds, and we have this line thunderstorms. I'm sorry I'm making this a bloodbath here, but you will get these slides, and if you request, you will get more of them. All right, so not to worry about my bloodbath. That's how I like to explain it. All right, so that's your line thunderstorms now that are taking place. Okay. Another traveling disturbance, and this traveling disturbance, okay, is known as your coastal low. Because it's a low pressure that's formed along the coast. It's going to play a big part when we're going to talk about Berg winds also, because it does have a big influence in the formation of Berg winds. Now, sometimes it's accompanied with a cold front, where at the center of the cold front, you'll have a low pressure system there. But let's look at what is a coastal low. Found along the coast, it generally originates on the west, moves along the coast towards the east. Okay, don't just say it moves from west to east. West to east means this. It moves along the coast from the west to the east, okay? And it can develop in summer and winter, of course, because the cold fronts can bring it. Now, learners, one point I know most resources will show it here. All right, a coastal low can also be found here. As long as it's along the coast, it doesn't have to be on the coastline to say it's a coastal low. And I noticed one of the previous papers that came out a few years back, because it was not actually on the coastline, people didn't recognize it as the coastal low. It can be a little away from that. So that is a coastal low. Now, air circulates in a clockwise direction, okay? In a clockwise direction, because it's a low pressure in the southern hemisphere. Okay, in the northern hemisphere, obviously it'll be the opposite. All right, now this is interesting, learners. These low pressure cells cause complete different weather on either side of the pressure cell. I want to draw a little sketch, and I hope I do my best. My southern Africa always changes. Sometimes it looks like a banana. Sometimes it looks like a valley. But anyway, I think that's not so bad. Okay, let's create a coastal low. Right, let's put one on the east now. There's my low here. All right, now look at the interesting thing. It moves in a clockwise direction. Am I right, learners? You learn that, and towards the low. Now, we get two types of conditions here, and that's interesting. All right. When it's moving in this one, let's make it number one. It's moving from the land to the sea. All right? So this is known as offshore. It's coming from the land to the sea. So it's off the shore. That's how you remember it. Offshore. Can you see it? Offshore winds. One side of the pressure cell, air will move from land to sea, will cause warmer, drier conditions, which means that it's coming from the land, so it's coming down towards the coast. All right, and if it comes down towards the coast, it's when air comes down, it heats up. There's evaporation, which makes it drier. So it's a warmer, drier air that comes from there. You'll see how we're going to use this in Berg winds now. All right, then let's look at number two. This is coming from the ocean to the land. So it's onshore winds. On the other side, the pressure cell, where the air moves from the sea to the land, it's moist, cloudy conditions that will lead possibly to rainfall along the coast, because now it's moving from the sea to the land. Can you see two different things? So offshore, onshore brings completely different weather conditions. It's so dynamic, learners, that these little pieces of climatological phenomenon affect our weather to such a great extent. So don't just read it out of a book. Learners, apply it and you'll see how your marks come up. That you can take this, you can put it on a synoptic map, you can look at the reasoning, you're taking your basics of climate and weather, about air movement, about heating up, about rising, about adiabatic heating, and you're creating these different weather conditions by looking at our climatological weather phenomenon. That's how it becomes so simple to understand. And we're going to say that's onshore winds, as I mentioned, and then the Berg pressure cells responsible for the Berg winds. All right, they're responsible for the Berg winds. And now I'm going to show you the Berg wind and what happens there. Okay. We're going to use this coastal low and the principles. So let us look at this. In order to remember this, Berg winds happen in winter. Remember that there's no Berg winds in summer. It's only winter. So, in order for Berg winds to occur, there must be a Kalahari high pressure system and a coastal low. Okay, now we've learned a Kalahari high pressure system must be well developed over the interior, and the coastal low, of course, at the coast. This can only happen in winter. Otherwise, Kalahari High is not that well developed during summer. So it's well developed during winter. We also learned that from the interior to the coastal region, there's a steep escarpment here. All right, a steep escarpment. All right, so what's going to happen? Remember, I taught you now, earlier on, I focused on the adiabatic heating when it's coming down. So imagine the steep escarpment. We know that the air will move from the high pressure towards the low pressure. And when it's coming down the steep escarpment, it's going to heat up adiabatically as it's coming down. Heating is happening. All right. And when heating is happening, we also have the process of evaporation, isn't it? When air evaporates. And as air evaporates, the moisture evaporates rather, the air becomes drier. So it's not just about it comes down the escarpment and it becomes a warm, dry wind. We must know the reasons why it becomes a warm, dry wind. Warm because it's heating up adiabatically. As it heats up, there is more evaporation, and if there's more evaporation of the air becomes drier. All right, and that is why there must be a well-developed high-pressure cell and coastal low-pressure cell. If there's no, see how I spelled that, I must put in a little A there. Coastal low-pressure. If those don't exist, there's not going to be a movement of air towards the coast. Air flows from the Kalahari high-pressure cell to the coastal low-pressure cell. All right? As air subsides, as I'm showing you here, all right, from the plateau down the escarpment, it heats up adiabatically. All right? And if it's dry air, it's 1 degree Celsius for every 100 meters. All right? And therefore, it becomes a drier and hotter air. Dry because the moisture evaporates as the air is heated. One more thing. Because it's coming from land to sea, it is an offshore current. Can you see that, learners? Okay. Brings uncomfortably dry conditions. Because it's so dry, it'll dry vegetation. People feel the dryness, all right, in terms of humans. Okay, because now everything is so dry, it can be linked to veld fires. Okay, because you just need to throw a match out of your window and there you have this massive fell fire over a short period of time. That is why you notice when you're traveling towards KZN through the Midlands, especially in winter, they have the strong boards saying, no, please do not throw lit cigarettes, etc. out of your car. You shouldn't be doing that anytime. Or you learners shouldn't be smoking. Eh? I hope not. All right. So you need to then be cautious because they can cause fell fires. It can be all types of damage. Infrastructure when it comes to economic, social, where it damage houses, farms get burnt, environmental, where crop vegetation dries out. If there's no water, it can infect livestock. You understand, erosion, etc. So it has all these effects that can take place in this situation. All right. I'm going to ask Portia if there's any questions at this stage. There's nothing, eh? Okay. So we're going to go on. All right. Another sketch here showing you this. This is quite a nice one also. Where we find the anticyclonic circulation that is happening in terms of the high pressure systems, okay? And it's moving towards the coastal low. And as it moves towards the coastal low, it heats up adiabatically. Can you see? Descending air reaches the coast as warm, dry air. So a different illustration. And you may be saying, why am I showing you different illustrations? Okay? Is that you get different sketches in your assessments that you do. You must be able to do past papers, learners. All right? In order when you do past papers, you then have a better idea. It's like a bit like your maths. You know, you try different little diagrams for geometry. Yeah, you use different sketches, all right, and different resources. And the more you use these resources, especially in things like climate and weather and geomorphology, you get used to answering, identifying the different phenomenon or climatological phenomenon, okay? Now, the next section that we look at is valley climates, okay? Valley climates. Now, various things we're going to look at. One is slope aspect. And now notice with the guideline learners, we have to define it. We have to look at the impact of it, etc. So before we look at things like anabatic and katabatic winds, and inversion layer and frost pockets, etc. Let's start with slope aspect. Okay. So what is slope aspect? All right. I'm going to go to that first on my next slide. All right. Slope aspect is the angle at which the sun's rays strike a slope. And you've already picked up, due to the location, all right, of the sun in relation to the slopes, in the southern hemisphere, north-facing slopes receive direct sunlight. And in the northern hemisphere, the south-facing slopes receive direct sunlight. And you know, it plays such an important part in terms of vegetation, settlement, okay, all those different factors. Like I want to guess here, Linus, I look at this. These are trees down here. Okay, this is shrub. I can just give you that and ask you, which is the south and north? Let's say this is the southern hemisphere. Okay, which is the north and south facing slopes? And just using a simple thing like vegetation. We know trees like cooler areas. All right, and shrub and maybe shorter crops like maize, etc., would like warmer climates. All right, or warmer. Okay, so of course, in the southern hemisphere, north-facing slopes are warmer and the south-facing slopes are cooler. So when I see the trees, I know this is the south-facing slope, and the shrub here tells me it's the north-facing slope. Can you see, just by looking at vegetation, we can actually determine that. But I know you know all this already, learners. You are excellent. And I know you did excellent in the prelim exam. Now you're waiting to nail the end of the year, especially for climate. All right. So we picked up that, right? That the angle at which the sun's rays strike. Learners, please note, if definitions come out, it is 2 marks. Okay, don't ever forget that. So we want full definitions. Otherwise, there's no 1 mark for definition. There's no vague, learners. It's either 2 marks or 0. Okay, so whenever you give a definition, make sure it's full. So let's look at what we learned from there. Northern hemisphere, south-facing slopes receive more sunlight. All right. Then north-facing slopes. In the southern hemisphere, north-facing slopes receive more sunshine than the south-facing slopes. We picked that up from our sketch now. All right. So in the southern hemisphere, north-facing slopes are hot, sunny, and drier because it's facing the sun. And the south-facing slopes are cool, shady, and retain more moisture. I showed you about the trees and the vegetation just now, how different the influences are. So, look at this. Soils on the cooler south-facing slopes are in the shadow zone because they're receiving less or not direct sunlight. All right, they're receiving oblique rays. Now, farmers, and that's where the importance of climate is, not just learning about a tropical cyclone. It impacts humans, all right? It impacts the environment. So let's look at farmers now. Farmers will have to settle on a slope that's best suited for certain crops. For example, crops that require less moisture and more sunlight will grow on the north-facing slopes, like your maize. You understand? In the southern hemisphere, obviously. And trees and shade-loving plants like ferns will grow on the south-facing slope in the southern hemisphere because it's cooler. All right. Also note that humans tend to build their houses on the north-facing slope. All right. Tend to. I know some people like very cold climate, so it can be subjective. But generally, we find even human settlements are impacted by which slope faces the sunlight. All right. And you know what? This gives so much relevance, learners, towards studying our stuff. It gives us purpose and therefore makes it easier to understand. So you will find that on most occasions, not on all occasions, that people tend to choose the north-facing slope in the southern hemisphere because it is warmer. Okay? It's warmer. All right? And that actually is not a nutshell. It covers your aspect of slope. Right. This is interesting. Okay. On a map, a topographic map, which you remember you're going to get, and you can get, as your prelim showed you, a topographic and orthophoto map. There's your river here. So that's your valley, isn't it? Okay. So the height is decreasing towards the valley. So we're sitting at something like that. There's the north there. We're having that, and we've got our river here. All right. So indirectly, or directly rather, not indirectly. All right. If we look at this, this is actually the south-facing slope. And what did we say about the south-facing? This is a part of a map in South Africa. What did we say about the south-facing slopes? That it's cooler and more moist. And what do you think will generally grow there? Even if it's natural vegetation, you will find more trees, etc. And can you see we have woodlands here? Isn't that interesting? That even nature decides we need cooler, moist climate. And that can be a question. We can ask it. You understand? Anyway, it can come out. Your teachers or whatever, tell us why there's woodland here. All right, and I think your prelim actually came out on that. All right, there was a question in your prelim about woodland regions. All right, oh, because you look at it, there's north there. That is the south-facing slope. Can you see how we can do these things? Right, just by looking at a little sketch or a map. So remember one more thing, learners, and I know I'm pointing my finger, I like doing that, is because it gets it into everybody's head. don't forget, each time you're doing things on climate, geomorphology, whatever, don't forget to see if you can apply it on the map. All right? And I know your teachers out there that every week, I know Ms. January tells me every week that this map work lessons are being there and we're picking up, and make sure you use that opportunity. Don't tell your teacher, it's map work again, because you're learning it to link it. And remember, your map work paper or the map work section of paper 1 will relate to climate and geomorphology. So there will be questions, and the more you relate, the better you perform there. Okay, I'm sorry, I'm always giving my lectures, but I must keep reminding you on that. All right, so there we are. All right. Is the anabatic and the katabatic winds. Learners, no other terms. And maybe I do apologize. I want to reflect a little bit on the guideline. The guideline has terminology. Please, we dealt with high pressures earlier, learners. We hear the word St. Helena high, continental high. Instead of Kalahari, we hear about mountain, valley breezes. Please stick to terminology that's indicated in your guideline. All right? The Kalahari high is the Kalahari high, not the continental high. There's no St. Helena now. It is the South Indian high. Use terminology, because learners, you may identify it and use terminology that may not be used in your guidelines, and it may not be marked correct. So please, here also, the big thing to notice, it's anabatic and katabatic winds, and that's it. Okay, anabatic and katabatic winds. Now, I'm going to go through this and I'm going to give you a break in between. I do apologize for that, because there's about a minute and a half. So I'm going to start off with this. Anabatic, katabatic. Simple stuff. Anabatic, I'm just going to put a word and I'm going to explain it after our break. Upslope. Katabatic, just when you're doing your little summaries, for you to remember better, downslope. Okay, that is your two pieces that you need to know. And when you please, learners, because this section is meant to score a lot of marks if it comes out. It's not difficult. All right. Immediately, when you write your heading, just in your notes also, put upslope, downslope winds, so that you're clear about it, because we find many learners mix it. All right. Another thing, before we take our break, anabatic, daytime. Katabatic, nighttime. You see the sun here, I know it doesn't look like a total sun. All right, and this looks more like a banana, but it's the night, it's the moon. All right, so you have your daytime anabatic, nighttime katabatic. So you know the differences, and those two things you remember, and you don't mix up the two concepts as such. I'm going to give you a 5-minute break, and remember, learners, it's only water, nothing else. I'm warning you, and we'll be back in 5 minutes. Okay, take a break.